Hi everyone, this video is on exercise 12K question 7. So we have a cylinder that has the total surface area of 600 pi. In part A, we want to show that the volume is given by this formula. So we first need to use the formula of the surface area of a cylinder, and that formula is equal to 2 pi r h plus 2 pi r squared. Okay, so in this case, we know the total surface area of the cylinder, and that's equal to 600 pi. So we can substitute that into the formula. So we have 600 pi. And for the next step, we need to rearrange this formula such that we can use this to find the volume. Now, before rearranging, we first need to know what's the goal. So let's write the formula of the volume of a cylinder, which is equal to pi r squared h. And this is the formula. So this means that we need to rearrange the formula of the surface area such that it can be substituted into the formula of the volume. And obviously the terms that we see that both of them have in common are they both have r and h. So we need to somehow find a way to write this formula in terms of RH or even r squared h, because both of them are going to work. Because we can also rewrite the formula of the volume as pi times r times h. So as you can see, if we can manage to rewrite this formula in terms of RH or even r squared h, we can substitute into the formula of the volume, and that's the goal here. So let's now rearrange this and see how can we get. So the first thing is that just dividing every term by pi. So we are going to get 600 is equal to 2RH plus 2R squared. That was the first step. And also for the second step, we can divide everything by 2. So we get 300 is equal to RH plus R squared. Okay. And if you notice here, we have the term RH, which is exactly what I just explained a few like a minute ago. So that means we can just write this formula, make RH the subject, and just have 300 minus R squared, because this allows us to substitute this into the formula of the volume. So we can then write that volume is equal to pi r times RH, but we substitute 300 minus R squared into that. And now let's expand and see if we get the same thing as the question. So we get 300 pi r minus pi r cubed. So yeah, that's exactly what we wanted to get. So this is the formula of the volume. For part B, we want to find a maximum volume of the cylinder. So again, this is an optimization question. The part B is optimization question. So that means we need to differentiate, then find the stationary point, which happens to be the maximum, and then finding the corresponding v value for that. So let's differentiate this equation with respect to r. So we need to find dv by dr. So we get 300 pi minus 3 pi r squared, and we set this equal to 0. So we need to solve the equation. 300 pi is equal to 3 pi r squared. So let's divide both sides by 3 pi, and we'll get 100 is equal to r squared. And the value of r is 10, because remember r is the radius, and that's obviously positive. So we have a radius of 10 centimeters. I think that's the units from the question. Okay, now we have the radius, but remember, we want to find the maximum volume in this question. So that just means we substitute the radius into the formula of the volume, which we found here. So that gives us the maximum volume. So V of max is equal to 300 pi times 10 and then minus pi 10 cube. And this gives us 2000 pi centimeters cube. So that's the maximum volume of the cylinder. All right, that's it for this video, and thank you for watching.